Welcome to the WION Podcast.
Right to be here.
Today we're doing a deep dive into something pretty wild from the world of exoplanets. A planet unlike anything we've really seen before.
That's right. We're talking about a planet with, well, the most elongated orbit ever discovered.
Yeah.
Just incredibly stretched out.
Stretched out. You mean eccentric?
Extremely eccentric, yeah. Think less like a circle or even a normal oval and more like almost a straight line path, swinging super close to its star.
Okay, so really close, and then...
And then incredibly far away.
Right.
We're talking about TIC 241-24953 b. It's about 1,100 light years from us.
Right, and this orbit isn't the only strange thing about it, is it? There's something about the direction, too.
Exactly. That's maybe the other really bizarre part. It orbits retrograde.
Retrograde, meaning backwards.
Backwards compared to the star's own rotation. You know, in our solar system, everything goes around the sun the same way the sun spins.
Mm-hmm.
This planet, it's going the opposite way, like driving the wrong way down a one-way street.
Okay, that is weird. So you've got this super stretched out orbit, and it's going backwards. Why is this particular oddball so important?
Well, it connects directly to a big question in planetary science. How do hot Jupiters form?
Ah, right. Those giant planets that orbit incredibly close to their stars, much closer than Mercury is to our sun.
Precisely. They're common, but how they get there is still debated. One major theory is called high eccentricity migration.
High eccentricity.
Like I said,
like this planet has.
Exactly like this planet has. The idea is that some planets start far out, like our Jupiter, but gravitational nudges from other planets or stars kick them onto these really long eccentric paths. And over time, tidal forces from the star, especially when the planet swings in close, gradually shrink and circularize that orbit, pulling the planet inwards until it becomes a hot Jupiter.
So this TI 241, whatever B.
TI 241-249-530 b.
Right. This planet could actually be in the process of becoming a hot Jupiter. We're seeing it midway through.
That's what it looks like. It's potentially a missing link. Assistant Professor Sarah Milholland, she put it nicely. She said this discovery supports the idea that this kind of migration accounts for, you know, at least some hot Jupiters.
And does she predict what happens next?
Yeah, she suggests it likely started as a cold world, far out, but give it about a billion years or so.
A billion years.
Ah.
Cosmic timescales.
Right. It'll likely settle into a very close orbit and become scorching hot. We're talking thousands of Kelvin. She called the whole process this big dance of orbits.
Wow. From cold and distant to roasting hot, all because of this gravitational dance. It really changes how you picture planetary systems. Not static at all.
Not at all. Very dynamic, constantly evolving. This planet is a fantastic example of that. A really captivating, bizarre discovery.
Absolutely incredible. A snapshot of planetary evolution in action.
Couldn't have said it better.
Well, that's all the time we have for this deep dive. Stay tuned to the WION Podcast for more such intriguing stories to come.